Okay, so we go to the back side here now and look at the third example. Here we get the population of a species of water beetle. Okay. After a certain number of weeks, between 0 and 8, it tells us, is given by this equation. Find the initial population. Okay, so this is back to one of the first kind of questions we did at the beginning of this unit, right? I want to, initial means no time has gone by. If I put 0 into this equation for time, 60 times 0, what do I get? And we said we could simplify these if we wanted to, or you can put it all in your calculator the way it looks. You can up with 5. Now remember, it talks about in thousands in the question, so this would be 5,000 beetles, right? It talked about the thousands up here. Okay, part B. What's the population at 6 weeks? Our time is being measured in weeks, so 6 weeks would be P at 6, or 5 plus 2 times sine of 60 times 6, which is 5 plus 2 times the sine of 360. And if we punch that in our calculator the way it looks, it turns out that is also 5,000 beetles, or the number 5, but remember it's in thousands. Okay, so apparently it's gone up and down back to where it started from in that time. Find the smallest and largest. Okay, smallest and largest. And then if I actually look ahead for a second in part D, when do those occur? Well, those are kind of the important points in my graph, right? If I think about it, and usually when we make a graph, we kind of make a table. So it might be helpful to make a table in this situation. So for C, I'm working with a good old sine curve again, 0, 90, 180, 270, 360. We know sine is these values. And what have we done to it? Our transformations. Okay. Oh, this is weird. Looking at things in the wrong order. Usually, we take this 5 and we put it over here, right? Think of that as my central axis. Okay, so what have I done to it? Well, the 2 out front, that's my amplitude. It affects the y as it stretches it. So 2 times my y. And then our central axis said plus 5, so it's moved up 5. So I've got to add 5 in there. And my x's, oh, it says 60. Remember, x's do the opposite, so we're going to divide. Okay, so we're going to get ourselves a new table. Our new table would look like x divided by 60. Okay, 0 divided by 60 is still 0. 90 divided by 60, 1.5. 180 divided by 60, 3. 270 divided by 60, 4.5. And the last one, 360 divided by 60 is 6. 2 times y plus 5, 5, and then 7, and 5 again. Then we'll get 3 this time, right? 2 times negative 1 plus 5, and then back to 5. Like we saw in our initial thing, right? Here was our initial, and here was after 6 weeks. Okay, now part C asks us, what is the smallest population? Well, our smallest, the minimum, is, what do we notice here? Oh, right here. Here's our minimum. Minimum of 3,000. And I can even say when that is. That would be during week 4, or 4.5, or at 4.5, right? At 4.5 weeks. And my maximum would be this one. Be a max of how many? 7,000 at 1.5 weeks. Now you notice I give you 2 different ways of answering this question, right? I said during week 4, because we had a 4.5, that would be the fourth between 4 and 5. Or I can say the words at, if I want to be more specific, 1.5 weeks. There's your min and your max. Okay, tables come back, they help us in all kinds of ways. Okay, very last question, last one for this unit. The depth in water in a harbor is given by this equation. Sinusoidal, making a wave, right? That makes sense, waves. Okay, write down the amplitude of D. Well, that's just picking and choosing from my equation. My amplitude is 4. Find the maximum. How do maximums occur? Well, we know they're the central axis plus our amplitude. Our central axis is 7, the amplitude is 4, so the maximum would be 11. And it says in meters up there. Find the period, but give it in hours. Okay. How do we find period? Well, that's usually 360 over k. So in our case, that's 360 over 0.5, which is 720. And I said to put in hours. Why did they do that? Well, they give it to us in minutes. So 720 minutes, how many hours is that? So 720 divided by the 60 minutes in an hour, 720 divided by 6 would give us 12 hours. Hey, on Tuesday, the minimum value of D occurs at 1400. That would be like 2 o'clock, right? Find when the next maximum value occurs. Well, we know our cycle is every 12 hours it goes through a whole thing, a whole period. So that means after 12 hours is one cycle. Then common sense says after 6 hours, that's half a cycle. And we know that the difference between the minimum and the maximum is always half a cycle. So if we go at 14 o'clock, 1400 hours, and I add 6 hours to that, I'll get 2000, or common vernacular, 8 o'clock. Okay, and that takes us through some problem solving, a little bit of everything in that lesson, right? Being able to work with equations, work with tables, make equations, and solve some simple problems. Okay, and that takes us to the end of the periodic functions unit. Again, don't forget to organize your tests with me.